Hi, control systems, time domain analysis and response of a second order system subjected to impulse input. To go further with the analysis, advise to have a prior knowledge about Laplace transform pairs and how a partial fraction is split in the go. Alright, so better to have a prior knowledge of Laplace transform partial fractions. What is that? The derivation, the analysis start from the transfer function of a, considering the general transfer function of a second order system. It's C of S in output by R of S input, which is equal to omega n square, the natural frequency, S square plus 2 zeta omega n into S plus omega n square. This is the general expression for a transfer function of a second order system, isn't it? So the response of a second order system subjected to impulse input and for various values of damping factor, let it be zeta greater than 1, zeta less than 1, zeta equal to 1 and zeta equal to 0. We have different values, right? Under damped system, critically damped, like that. Undamped system, various values, four different values of zeta, 4 names we have for the second order system, isn't it? So checking what will be the behavior of what is the final expression, what is the final expression says for all that 4 cases. All right, and with this one, and R of S is the input, and in our case it's a impulse input. The Laplace transform of impulse input is 1, and C of S, now R of S is 1 over here in this case in our discussions. All right, keep that in mind. So 1, the Laplace transform of impulse input. So going that side, it's a 1 multiplied with a 1. So this is our final, we start from here into 1, R of S, the Laplace transform of impulse input being 1. From that we carry the analysis. All right, and guys, this is a coded expression, this one very much similar to our ax plus ax square plus bx plus c. All right, so a is 1 and 2 times zeta omega n is a b value and this is our c value. So what do we have? 2 roots for the coded expression, which is minus b plus or minus under root b square minus 4ac upon 2a, isn't it? So this is expression 2. So plugging in the values, extracting the values of a and b and plugging in over here, what do we have? 2 roots, two roots. All right, and what it is, b is our 2 zeta omega n, negative 2 zeta omega n plus or minus under root b square. It's again the same thing, 2 zeta omega n, but square in terms of square, isn't it? So 4 zeta square omega n square minus 4 a, it's 1, and c, it's omega n square upon 2, it's a1. So that's it, the roots, we are 2 roots. All right, so guys, this, taking out this as common, this 4 and this one as common from these 2 terms, this. All right, so that will result into let me take it here itself. All right, so this zeta square from the first term and negative 1 from the second term. So what it is, zeta square from the first term and minus 1 from the second term. What do we have? 4 omega n square. So this was the change. All right, this is the change we have. And here itself, taking this 4 omega n square out of this root, so what that results, is, let me write it over here, plus or minus 4 came out from the root, it's a 2, omega n square came out from the root, it's a omega n, and taking out that term from the root. All right, so this one will be the resultant, and this 2 is applicable for this as well as this. All right, so this gets cancelled here, this gets cancelled, and here gets cancelled, and we have the 2 roots, minus of 1 is S1 root is minus zeta omega n, a positive omega n into under root zeta square minus 1. This term is under the root. All right, keep that in mind and carry out the analysis accordingly. And the second root, S, is the same thing, minus of zeta omega n minus second, plus or minus, we have plus or minus, right? One is first time it's positive and negative, omega n into under root zeta square minus 1. So how can this be written? It's RHS, it's negative. So pulling this to LHS, that will be this one, this entire black. All right, marking with the black. This, no, not that one, not that one. I'm sorry. So this one, this part. S equal to this one, isn't it? So what it says, it's a equal to positive times of this one, right? So let me pull that to the LHS side, and that will result as close the bracket, minus, which is equal to 0. All right, in the same way with this entire this thing, and minus of entire this, which is equal to 0. So this is how we can write the root, isn't it? This is how we write the root. This one, that was positive, this entire bracket, that was positive, so pull this one and gave negative. The same with this one. So now this equation can be written like which way? This equation, the first equation which we considered, can be substituted with these two roots, isn't it? So what is that? This is the same. C of s will be equal to omega n square from the previous, and this one, two roots. So this one, this entirely, this into this will give us this. All right, so s minus of minus zeta omega n plus omega n into under root zeta square minus 1, close the bracket, and this one for the first root. All right, and open the bracket again for the second root, s minus of what it is, minus zeta omega n, right? And for the first root it's positive, and for the second root it's negative, omega n into under root zeta square minus 1. All right, and red one to close this one. All right, so these two are different, the roots are distinct. And so that procedure to split into partial fractions, one need to have an idea on that one. This fraction can be split into its partial fractions. All right, let me not waste your time. It's simply this numerator will be, okay, let me have this one. Why? Because we have to get back to this one. It's a omega n square. Now this could be split into a upon the first root, s minus of minus zeta omega n plus omega n into under root zeta square minus 1. All right, plus for the first root, and b upon s minus of minus zeta omega n minus omega n into under root zeta square minus 1, close the bracket for the second one. All right, now we have to evaluate the values of a and b individually. All right, plug in over here, then we have to carry out the analysis. All right, so that procedure to evaluate a, all right, so getting back to C of s, the C of s is multiplied with the a residue, this residue. To evaluate a, we are trying to evaluate a. While we try to evaluate a, C of s, then C of s, which is this expression, is multiplied with the a residue, is multiplied with a residue, this one, s minus of minus zeta omega n plus omega n into under root zeta square minus 1 multiplied with that one. And okay, when this is multiplied, when C of s is multiplied with this one, this term, all right, this term and this gets cancelled. All right, so that gets cancelled, and so what is left over? We are evaluating for a, isn't it? What is left? Omega n is not cancelled from this one, upon these two are cancelled. All right, so we don't have that anymore, and we have s over here. This s is plugged in with this one. Now this one will be only with this one, only this s is plugged in with this one, this value. All right, so what is that? s, in the place of s, that comes, so that is negative omega, zeta omega n plus omega n into under root zeta square minus 1 from this one, alright, and this will exist as it is. This will exist as it is. This into this, it's a positive zeta omega n. This into this, it's negative, so negative into negative, that will be positive omega n into under root zeta square minus 1. Did I go wrong? No, not at all. So omega n square as it is, alright, and guys, this negative zeta omega and positive zeta omega, this gets cancelled, and it's one time omega n under root zeta square minus 1 and another time, so it will be 2 times omega n under root zeta square minus 1. So what gets cancelled over here? The square and omega n, so a will be left over with that one, that value. What is that? A will be left over with, a will be omega n upon 2 times under root zeta square minus 1. It's in the bracket, alright. Yeah, keep that in mind. So that's the value of a. Now what to do with the b? Same, alright. I'm removing this one. The same procedure. This time c of s is multiplied with the b residue. Alright, so it's multiplied with the b residue. It's a into c of s into s of s minus zeta omega n minus omega n into under root zeta square minus 1. Alright, so with this multiplication, this term, alright, this term and this term gets cancelled. So we are evaluating for b, alright. B will be equal to this, it's not cancelled, omega n square comes down as it is, and we don't have this term and this term, alright. So we don't have these two, and in the place of s, this value is to be plugged in, this value, so that gives us minus zeta omega n minus omega n into under root zeta square minus 1, alright, in the place of s, and this will continue as it is, negative into negative positive plus zeta omega n, alright, negative into positive, that is negative, it's a omega n into under root zeta square minus 1. So something gets cancelled, this negative and positive, that exists no more. I'm erasing this away for my convenience. Here that exists no more, and 1 time and 2 times, that will be omega n square minus 2 times this one, alright, for my convenience. And after this, even we don't have this anymore, this gets cancelled, so this is the final expression for b also, alright. So this is the expression for b, we don't have this anymore. And here, so these a value is plugged in with that one and b value is plugged in with this one, alright. So that will lead to c of s will be equal to, what's a? It's a omega n upon 2 under root zeta square minus 1, and this one as it is, 1 upon s minus a, this entire, this is as it is, 1 upon, what is that, s minus of minus zeta omega n plus omega n into under root zeta square minus 1 as it is, right? Only in the place of a we have plugged in that one, this appears as it is, so this is done, and a also is plugged in, plus in the place of b we plug in this one, we have this negative, alright, so it's no more positive, it's negative, that negative comes over here, this is no more positive because of beta value is this one, negative omega n upon 2 times under root zeta square minus 1, only in the place of b, and this appears as it is, it's 1 upon s minus of minus zeta omega n and minus of omega n into under root zeta square minus 1, close the bracket. right? So this is the final, I mean not final, the deduction. Something can be taken out as common from both terms, guys. This and this are same and can be taken out as common from both terms. So let me do this one. I am erasing this one, and so that we can save some time. All right, so this is the one. And guys, this is a standard. Now we have come to a standard Laplace transform pair. Almost, it's 1 upon s minus a, 1 upon s minus a, and the inverse Laplace transform, obtaining the inverse Laplace transform for the entire expression. It's no more c of s, it's c of t. It will be time domain, which is equal to omega n into twice zeta square minus 1. All right, 1 upon s minus a, inverse Laplace transform 1 upon s minus a, that will be resulting into e power. If we have negative, we will be having positive, isn't it? E power a into t, the inverse Laplace transform standard. So this was the thing I asked. It's a minimum requirement, the knowledge to be to go ahead with the analysis. All right, so that will be, and this can be reduced to what? E power, it's negative, so we'll be having positive e power, what's a, minus of zeta omega n plus omega n into under root zeta square minus 1 into t. All right, for the first term. And for the second term, this negative comes down as it is. Even this 1 upon s minus a, e power minus zeta omega n minus of omega n into under root zeta square minus 1 into t, e power a t, isn't it? So big bracket to match this one, to complete closure. All right, so what is this t2 doing over here? Can this be this one? By 2. It's e power at minus not yet, I'm sorry, not yet, there is another simplification, omega n into under root zeta square minus 1. Guys, taking out these, something can be taken out as common from both terms here. This one, this negative, and exponential rise to this negative can be taken out as common. All right, so what is that? We have that too, e raised to negative zeta omega n t, this into this, isn't it? How can that be neglected? Close the bracket. We have e raised to omega n into under root zeta square minus 1 into entirely t minus of e raised to we have this negative. All right, negative minus of omega n into under root zeta square minus 1. Here we have positive and there we have negative into t upon 2. So guys, it's not 2j, it's not 2j, and we don't have any j over here. E power at minus e power xt minus e power minus xt by 2, that will be hyperbolic sine h at sin h xt, like that. All right, so c of t, the c of t will be equal to omega n upon under root zeta square minus 1 e raised to minus zeta omega n into t, and this can be closed as sin h hyperbolic xt. So this will be like a or x, whatever. It's a sin h of omega n into under root zeta square minus 1 into t. All right, so this is the response of a second order system when subjected to impulse response and zeta being greater than 1. Critical, it's not over damped, I guess. Check that. And this is the expression. All right, this is the expression for that one. And the second case is when zeta is less than 1. A little bit something to understand over here. All right, so once again we start the analysis from that second order system, the transfer function of a second order system. All right, so we have to go back to that expression for second order system it is once again C of s, R of s is 1, impulse response, the Laplace transform of impulse function is 1, so R of s that side, the same thing R of t, I mean that one, which is equal to omega n square upon s square plus 2 zeta omega n into s plus omega n square, isn't it? So previously we had something else. What was that? S 2 roots s, the same thing, only there is something 2 steps that has to be included and understood. All right, so what if minus zeta omega n plus or minus omega n into under root zeta square minus 1. So guys, take a pause and look at, watch, listen to my points very carefully. Zeta, no, zeta, for the case zeta less than 1. All right, this something under the bracket, inside the bracket, doing some analysis under the bracket. All right, what was over here? Zeta square minus 1. All right, one thing, if you have a calculator in your hands, put me in pause. Plug in the value of zeta to be 0. The very next value, the very previous value to this one, 0.9 whole square minus 1 under root. If you are in imaginary, I mean if your calculator is in imaginary mode, you'll have j term, or else if you are not in imaginary, your calculator will show math error. Check that one. All right, so we need to take out that j in the beginning itself. That's the point over here which has to be. All right, so okay, if you don't understand this one, listen to me very carefully. Can this be written as minus 1 into minus 1 over here? It can be, isn't it? I am rewriting it again. All right, zeta square, we had zeta square, no change in that one. Can this be written as minus 1 into minus 1? Will there be any change? No, isn't it? And we have that minus 1 into 1. All right, so guys, taking out negative 1 has come from here and here, so what that results, minus zeta omega n, positive and negative omega n under root minus 1 is common from both the terms, minus 1 has come out, so what will we have? We have 1 from here, negative 1 has come out, so we have 1, and 1 negative 1 has come out. What are we left with? Minus zeta square, 1 minus zeta square. All right, and both terms are inside the root, isn't it? So the root is applicable for this one and even this one, so root minus 1 under root minus 1, what it is. So taking out negative outside this one, and root over here, okay, we have that root and we have this root also, under root minus 1. So what is this? Under root minus 1, it's a j, isn't it? So that j is taken out in the beginning itself, it's a j. All right, it's a j. So we have to carry out the analysis for the same analysis for this one. All right, whatever we have done to arrive for this one, the same thing. And how to write down this one? This expression can be written for C of s will be omega n square upon the same like the previous one. All right, so close the bracket for s minus of minus zeta omega n positive j omega n into under root it's 1 minus zeta square this time. All right, 1 minus zeta square. Close the bracket for this one and close the bracket for this one. Another root is s minus of minus zeta omega n. It's positive for the first root, it should be negative for the second root, j omega n into under root 1 minus zeta square. So guys, be careful for this one and for that one. All right, previously it was zeta square minus 1, now it's 1 minus zeta square. All right, keep that in mind. So analysis is carried out for that one. And watch carefully, this for zeta less than 1, underdamped case. All right, so the analysis is for underdamped case. Do we want to have this one? No. Why? Because we have to carry out the analysis with this expression. All right, once again, splitting into its partial fraction, it's a distinct root, and so C of s can be written as a upon this one, s minus of minus zeta omega n plus j omega n into under root 1 minus zeta square, close this one, for this one, for the fourth root, all right, plus b by s minus of minus zeta omega n minus j omega n into under root 1 minus zeta square, close the bracket. So for the second one, all right, so this is the one, and we need to evaluate just what we have done with the previous analysis. Evaluating a and b will give us the simplification towards u of t, the inverse Laplace transform, whatever. Now once again, how to evaluate a is C of s is multiplied with the a residue, and that is C of s is multiplied with the a residue. Let's do it over here, is multiplied with whatever a into s minus of minus zeta omega n plus j omega n into under root 1 minus zeta square, close the bracket. All right, so if it is multiplied with this, I mean a residue, this term and this term gets cancelled, and what do we have? This one, a, we are calculating for a, so for the time being, okay, this and this term, these two terms gets cancelled, these two terms gets cancelled, and omega n square as it is from the previous term, omega n square, and we'll be left with this one. In the place of a, sorry, in the place of s, this has to be plugged in, this one, this entirely, this has to be substituted, which we have done very previously. So that one, that negative zeta omega n plus j times omega n under root 1 minus zeta square, for in the place of s, all right, in the place of s. All right, this got cancelled, we have this term, and in this term we have s, and s should be plugged in with this one, and this carries this, this has to be written as it is, negative into negative positive zeta omega n, and negative into negative positive j omega n into under root 1 minus zeta square. All right, so I'm erasing this one, or else I'll be confused if what I'm doing. All right, so guys, something gets cancelled. We have negative and positive, we don't have this anymore. All right, we don't have this anymore, and what, 2 times, all right, we have this one 2 times, so 2 times I'm erasing this one. So this is the expression for, this is the value of a, all right, this is the value of a. So following the same procedure, if we go forward with the b, so b will be like the previous one, b will be negative omega n square by 2j omega n into under root 1 minus zeta square. All right, so plugging in the values of a and b over here, what do we have? C of s will be equal to a, in the place of a we have this one. All right, so what is that? Omega n square, and taking out as common, okay, let me reduce the number of steps, let's save time. So a and b as common, this only the negative exists, so I'm taking it out, okay, yeah, by 2j into omega n into under root 1 minus zeta square, isn't it? So here itself this exists no more, make a mark of this one, we don't have this anymore, into 1 upon s minus zeta omega n plus j omega n into under root 1 minus zeta square inside the root. All right, so this one from this one, and what about, we have this negative, isn't it? This negative will appear over here, so negative 1 minus this comes as it is. All right, s minus of minus zeta omega n negative j omega n into under root 1 minus zeta square. Alright, so close the bracket to close this one, right? So yeah guys, now applying the inverse Laplace transform. Inverse Laplace transform on either side, it will be c of t, it will be c of t, and omega n upon 2j under root 1 minus zeta square, that will be as it is, no change in that one. And this similarly like the previous one, 1 upon s minus a, so it will be e raised to positive minus zeta omega n plus j omega n into under root 1 minus zeta square, close the bracket, into t. 1 upon s minus a, inverse Laplace transform, that will be e power positive at, isn't it? So t, we are converting that in time domain, and this negative appears as it is, and e power this as it is, so it will be minus zeta omega n minus j omega n into under root 1 minus zeta square, close the bracket for this one. Alright, so guys, here I think it's not thinking, it's the reality. This one, this entire term, and this, and sorry, we need to multiply this with the t, isn't it? Why? Because it's inverse into t. Alright, this multiplied with t, this in common multiplied with t can be taken out, I'm taking that out as common from both the terms. Alright, so this one, what is that? e raised to minus zeta omega n into t as common from both the terms, so we'll be having exponential as it is. Alright, we don't have this, this is taken out, we have that, only that exponential, we have that exponential minus, and also this 2j can be written over here, 2j. So guys, watch carefully. This considering this to be entire some x or theta or something like that, t or a, it's e raised to positive j theta minus e raised to negative j theta by 2j. It's a hidden sine theta according to Euler's identity, that can be close to Euler's identity. Alright, e raised to j theta minus e raised to minus j theta by 2j, that's a cos theta, sine theta in terms of Euler's identity. So c of t, our final expression for c of t will be equal to omega n upon under root 1 minus zeta square into e raised to minus of zeta omega n into t. This entire thing will be sine theta, alright, into sine of omega n into under root 1 minus zeta square into t. So it's a sine function, like damped, decreasing, damped sine function. Alright, so this is expression for final expression for second order system subjected to impulse input when the damping ratio is less than 1, under damped case. Alright.